Today we're talking about robots that move through the magic of mushrooms. But before we get into that, Google Meet is getting a new AI tool called Take Notes for Me, which will generate summaries of key points during a video call. Rather than offering a word-by-word transcription, this feature uses Gemini AI to record key discussion points in a Google Doc that will appear in the meeting owner's Google Drive. The document can be automatically sent to the attendees or added to the calendar event after the call. It will also include links to the meeting recording and transcript if those features have been enabled. Google Workspace customers with the Gemini Enterprise, Gemini Education Premium, and AI Meetings and Messaging add-ons will be the first to have access to this note-taking feature. Its use is currently limited to English language and to meetings on computers or laptops. The tech company announced plans to include generative AI in more services last year and has been aggressive in putting AI features into its hardware and software since then. Its Gemini AI assistant is getting baked into Android and into its Workspace apps. As always, the usefulness of these features may vary depending on how well the AI works and how accurate it is. The specter of Google's AI overviews telling people to eat glue pizza will likely continue to hang over its ongoing efforts in this space. Researchers at Cornell University tapped into fungal mycelia to power a pair of proof-of-concept robots. Mycelia, the underground fungal network that can sprout mushrooms as its above-ground fruit, can sense light and chemical reactions and communicate through electrical signals. This makes it a novel component in hybrid robotics that could someday detect crop conditions otherwise invisible to humans. The Cornell researchers created two robots, a soft spider-like one and a four-wheeled buggy. The researchers used mycelia's light-sensing abilities to control the machines using ultraviolet light. The project required experts in mycology, the study of fungi, neurobiology, mechanical engineering, electronics, and signal processing. The fungal robot uses an electrical interface that, after blocking out interference from vibrations and electromagnetic signals, records and processes the mycelia's electrophysical activity in real time. A controller, mimicking a portion of animals' central nervous systems, acted as a kind of neural circuit. The team designed the controller to read the fungi's raw electrical signal, process it, and translate it into digital controls. These were then sent to the machine's actuators. The pair of shroom bots successfully completed 3 experiments, including walking and rolling in response to the mycelia signals and changing their gaits in response to UV light. The researchers also successfully overrode the mycelia signals to control the robots manually, a crucial component if later versions were to be deployed in the wild. As for where this technology goes, it could spawn more advanced versions that tap into mycelia's ability to sense chemical reactions. In this case, we use light as the input, but in the future, it will be chemical, according to Rob Shepard, Cornell Mechanical and Aerospace Engineering professor and the paper's senior author. The researchers believe this could lead to future robots that sense soil chemistry in crops, deciding when to add more fertilizer, perhaps mitigating downstream effects of agriculture like harmful algal blooms, Shepard said. Thanks for listening to the show. Make sure to rate, review, and subscribe on Apple Podcasts. Today's show featured journalism by Engadget contributor Will Shanklin and was produced by Spoken Layer. I'm Imran Sheikh, and as always, we'll talk more tomorrow.
Spoken Layer.